Lesson 3.6, we want to look at what a proportional relationship is and how to determine if something is proportional. So first of all, our definition for proportional relationships. A relationship is proportional if it meets the following three criteria. First of all, it has to follow the equation of y equals kx, meaning we have to have some kind of constant of variation. So we're increasing by a constant rate or decreasing by a constant rate. So this is going to be a linear equation. It's going to have a straight line for a graph. Second of all, that k term cannot be 0. It has to be something else besides 0. And lastly, the graph must pass through 0, 0. Those are three criteria. The equation is y equals kx, k is not 0, and the graph always passes through 0, 0. And as a note, this means that all direct variation equations that we looked at in 3.4 are considered proportional relationships. Let's look at a few examples. I put my three criterion up here in the top right corner of y equals kx is our equation, k can't be 0, and it must pass through 0, 0. Let's look at this table. First of all, does it fit the equation? Is there a constant of variation as we move up? So from the top part, we're obviously adding 1 each time, and it's pretty obvious. You can see it adds 1 every single step. On the bottom, from 75 to 150, we are adding 75. From 150 to 225, we're adding 75. And so on each time. We are adding 75. So we have a constant, so that checks out. Our constant's adding 75 each time, so our constant's not 0. The last thing to check is, would it go through 0, 0? If we plotted this on a graph, would it go through 0, 0? So if I went backwards, if my x was 0, my number of goals was 0, what would my donations be? Well, notice we're adding 1 each time, so to go backwards 1, to follow the same pattern, just reverse it. So instead of adding 75, we would subtract 75. And so 75 minus 75 is 0. And so yes, it would go through 0, 0. So that checks out. This would be considered a proportional relationship. Next example, we have another table. And again, you'll notice on the top, we're adding 1 each time. And the bottom, very simply, we are subtracting 1 each time. So we have a constant. It's -1. So it meets the first criterion and the second. Lastly, would this go through 0, 0? So if we backed it up 1 and x was 0, what would y be? In this case, we backed up the 3. Instead of subtracting 1, we would add 1 to go backwards, would be 4. And obviously, 0, 4 is where it would pass that y-axis and does not go through 0, 0. Therefore, this would not be a proportional relationship. In equation form, it's a little easier to see whether or not something is proportional or not. Really, all it has to do is mimic this equation on top of y equals kx. First one, y equals 3x, k would be 3, so k is not 0, and it meets that equation, which means it will ultimately go through 0, 0. So this one is proportional. The second one I put in function notation. So f of x is equal to 2x plus 1. Remember, this f of x is the exact same thing as y. We're just using a different notation. So this is the same thing as saying y equals 2x plus 1. But you'll notice there that this plus 1 at the end is not in that y equals kx, and so this is not proportional. Our last example here, f of x equals 2/3 x. This meets our y equals kx pattern. Again, f of x and y are interchangeable, just a different way of noting the function. Our k here is 2/3, which is not 0, and there's nothing else extra added on, so this would also be proportional. The last thing we're going to look at is from graphs. And with graphs, the big thing we're going to look at is it linear? Do we have some kind of constant, some kind of slope? is that constant something besides 0, and does it pass the origin? In this case, we have definitely a linear graph. It's very simple. It's going up 3 every time we go over 1. However, it passes up here instead of down here at the origin. So this is not proportional because it does not pass through the origin. So that's our basics for proportional relationships. There is one more thing I want to add. It's a little trick. And that is, we can actually determine from a table whether or not something is proportional by seeing if each coordinate creates equivalent fractions. So we already know that this one was proportional, and this one was not proportional. So if I make these into fractions, would 1 over 75 equal 2 over 150? And this is obviously yes, because 1 times 2 is 2, and 75 times 2 would be 150. Now let's look at their second equation. If I make these into fractions, I'd have to say that 1/3 is equal to 2 over 2, which is obviously false. 2 over 2 is the same thing as 1, and 1/3 is not equal to 1, so that would not be proportional. It's not equal fractions, so that would then be non-proportional. So that's just a little trick if you're looking at tables, which is probably one of the harder ones to look at to determine whether or not a proportion or relationship is proportional.